Right, this is a quick run through, a very quick run through the questions that are on sample paper A from Educate.ie. Not going through this here because it's pretty straightforward. You need to know how to draw a pentagon here. You're given the 2 points to start off, whatever method that you use, whether you want to use protractor or whether you want to go down the route of the 45 and 60 degrees method and then dividing the distance on the side, getting the circle, drawing your pentagon. The one that's on the inside, obviously you locate the 2 points, and the easiest way is probably to go parallel and use the compass to get the distance of the sides. Not going through the pie graph or the angles. This here, you have to draw 2 random chords. You're given a circle to get the center. Draw 2 random chords, bisect them, and that will get you your center. After that, it's straightforward of drawing the pattern. Joining up your developments with the objects here, the solids, is fine, straightforward. This one here, make sure you try and get some sort of proportion to what it is that you're trying to draw off the lunchbox here, and a wee bit of render. Don't kill yourself with the render. Just make sure lines are parallel, vertical lines are vertical, that sort of thing, and a kind of a structure to the proportion. My outline's probably a wee bit heavy on that. This one here, percentage, is simple. This here is an axial symmetry, so it's just whatever distance you come out to the left, you come out to the right as well too, and it's a matter of drawing straightforward. This one here, a wee bit trickier in that you have to draw a triangle ABC. The ratio is 345, and the line that's given to you is the circumference of the outer perimeter of the triangle, the perimeter length. So you have to divide the distance from x to y, was the 345 is 12 equal spaces. Don't take all the parallel lines, just come from 3, then 4, which is 7, and then your 5, which is 12, and then you can rotate these here into place, and it gets you your proportion 3, 4, and 5. I've had it done a wee bit different there, and labeling it doesn't really matter, ABC, whichever. This one here is your octagon. You need to make sure that you're using your 45-degree set square for starters anyway, and then of course the PQ is given to you, so you can swing the arc, and coming off at 45 degrees, and there's loads of ways of doing the rest of it then, so that all the distances should be nice and symmetrical. This is the first big question on the paper, which is your orthographic projection. Work out the overall sizes, overall height. You can see I have a wee box drawn here showing the overall length of it here, this way the overall height, and then the depth of it as well to work it out. Some of the times they mightn't be the most obvious looking at them straight away, so take a bit of time on that, because that'll allow you to know how far to come down for the XY and how much space you need for the plan as well, and start working through the elevation at the start, because you have your curves, and to get these points exactly in the plan you'll need your elevation. Now there's nothing to stop you from working one to the other, but that's the way I will go about it. And the other thing then is you to get the true shape of S. So what I've done here is I've taken C, this point C here as a center point, and rotated that side around. I don't have enough room to turn it around to bring it up to the elevation, so I'm just going to extend it out here. So I drew a parallel line here randomly anywhere, x1, y1, and I projected it out that way. And the height of S here, I've taken it out along here, and you can see that's parallel to that. So that gives me my true shape then. So it's just a rectangular shape. First big question is worth taking a bit of time, maybe seek that out at the start. Which is the big questions? Tackle them first maybe. This is just measurements, so I'm not going to spend any time on this. A wee bit of time on this one here, in that how did I do it? A to 0 I've rotated to get where A is on this line here, because this object is going to be rotated to where A touches the ground. What I done then was this center line here and this angle line here, I just took that angle, I measured that angle, and I drew it out here, so the angle is the same out here then as well too, right? Once I get that center line, I can rotate my center to it, which also can take my radius, because it's the same thing, it's not going to change in size. So I had the point here, I have my center point, then I can extend it on out, rotate it around to get that curve. Then I only need to get this shoulder part here, and I can take that down to get the center point off it, and obviously that's 90 degrees off the sides. It's going to be 90 degrees off the sides there, so you use your 2 set squares to get that. Really simple. This one here, you're given the ball, so you take the radius of the ball and you set it on P and you set it on Q, scribe the arcs, get you your center. nice and handy one. This one here, the one on the left, easy with all your curves and the cone. This one here, the parabola, you could just use 4 points. I used 5. Key things here though, make sure you know where your vertex is, and make sure that you follow this then, that the line along the vertex, you go parallel to the axis, and then the line parallel to the axis, you go at an angle from the vertex. Sometimes it's handy to just draw a rough sketch of that out if things turned around or whatever. So take them at points at a time. So 1 comes parallel to the axis, this comes at an angle back to the vertex. 2 parallel to the axis, and then back to an angle. Nice handy one. The sketch in it, so needs to kind of represent it. It doesn't have to be accurate. So anything that looks like it, and that's tricky enough actually, but I wouldn't be wasting much time on it. This one here, you're given the axis, the major minor axis. So I used a trammel to draw this here. If you use concentric circles, that's fine, whatever one you're most comfortable with. I find the trammel is far superior to the concentric circles in lots of ways. Then to get the focal points, take half the major axis, and from point B to the axis is half the major axis. Will you use a compass or you use your trammel? That's fine, doesn't matter. Center of this circle is easy to get, 30 degrees, then it's what, 21 millimeters out. No big deal there. You can't draw the neck this until you would get your circle drawn. Then you take this line up and you have the distance from here to the center line of that, and you have to come out again to be able to get the other part of it. This is straightforward to 18 millimeters out from the edge of the circle, 6 millimeters either side, join back to the center and get you your point. Kind of a big question, and one worth doing. Hopefully you'll give marks for that. And this here sketch, you can see my sketch is not the best in the world here, but the proportions are important when you're trying to draw it. Run off a center line, run where each of these things are. Perspective, just project everything back to the 2 vanishing points and try and work out the stuff that you haven't got. I'm not going to go through all that. Hexagon, 30 degrees in this instance here, but even though it's a 60-degree side. Then the center for the arcs, put your 33 center and draw the arc. One wee tricky bit in it here is at the bit at the top where you're drawn, you're given the radius here of 8, and that's not easy drawing in a compass and being accurate with it. So I have one of these guys here that I use quite a bit for small radii circles, and it just makes life an awful lot easier. But that's straightforward. You're also given a wee bit of a start point in it. This one here is a wee bit trickier, and if you just ignore everything that's going on here and just look at AB and C2, AB increases to AB1. So obviously this is a perpendicular line, there's a vertical line, it has to be vertical. So it takes C2 out to here, gives me the new C2. Once I've got that, I can draw the semicircle or the quadrant of a circle. Then to get C1, I extended it out to get a line vertical there again, and I can draw the radius again and take it across to where it hits this line. To get this point down here, I just go parallel to that line there, and it gets me the last line. So it's just an enlargement. It's handy enough. This is the next big question will be on it. 2 parts to it. The box part, or rectangular kind of shaped part. There is an incorrect line that's on this here that shouldn't be in it. It kind of throws you a bit as well too, so you just want to make sure you know that distance there is that distance, and then your radius, that height has to be here, and you have to draw that in. If you want to think about that as your elevation and divide it up, of course it's at a bit of an angle, and you have to do this here as well too. So locate each of your points so you can see 0, 1, 2, 3, 4, and you see I have a tangent point here as well too, P, which is just taken out at 60 degrees there. 5 and 6, and then project each of them back, probably key ones first, 0 and 6, and then take 3 and locate each of them. Once you have them key points 0, 3 and 6, it's only a matter of getting the ones in between them. So that's the next big one, and this is the last question on the paper. Bit of rendering to go on here, which is straightforward enough. I like to use colour because it's a wee bit quicker than using the pencil. It takes a lot of time to build up pencil. And the last wee bit of this thing here, you are given the centre for this here, you're given a location of each of the other circles, so you're able to draw your circles lightly. I take this point through here and out here, get the point of contact, and even though I'm given the radius and all the rest, you're not given the location that there. I think is what it is you have to take 107 radius to get there, and then you're actually able to get this other one as well. Then the other thing I like to do here is like just draw a random line and a random line from the two centers of two circles when you have a curve in contact, and add on my radius, which is 62 and 62 here. Add them on physically with a compass because you'll not make any mistake in transferring the sizes. Then from the center, rotate the two of these back, and where they intersect, don't forget to join the center to center to get the point of contact, and then you can draw a nice accurate curve. And that is the paper kind of run through very quickly on each of the questions that's on it.